This lesson is on definite integrals. So we have done indefinite integrals, and that's when you have an integral without these a and b values. So we've done indefinite integrals, so now we're going to do definite ones. So definite ones are where you actually have the numbers for a and b. So now that we've learned how to find antiderivatives, so you know how to find an antiderivative when you're a constant, a polynomial, or a trig function, now you're able to do that. Now you can find the area between the curve and the x-axis, and you can do it without using sigma notation. So previously we always found the area between the curve and the x-axis using sigma notation. So either just the sigma notation where n goes to infinity, or with a Riemann sum. And so both of those were ways to find the area between the curve and the x-axis. So now we're going to figure out how you can do that with just an integral. So that requires the fundamental theorem of calculus. So we've done this before, and so you have this written in your notes. So just double check that everything is accurate, that you did write this correctly in your notes. So the fundamental theorem is saying if you have a function f and it's continuous, and you can find its antiderivative, and that's capital F, then when you take the integral of f, you get its antiderivative, which is big F. And then if you have these values for a and b, you just plug those values in. So you'll have that the integral of f is its antiderivative, and then you just plug in b, and then you plug in a, and you subtract those, and it's always in that order. So it's big F of b minus big F of a. Okay, so you'll subtract those. So we'll do a few. Okay, so the first one, evaluate the integral. So all of these, A through E, are evaluating the integral. So we are going to be evaluating the integral here. So remember that this can be translated as area between the curve and the x-axis. And remember that with Riemann, we found that the area can also be below the x-axis. And so all we have to remember there is if you're below the x-axis, you are negative area because your y-coordinate is negative. If you're above the x-axis, you're a positive area. So let's first start this one with just the area idea. So let's just sketch this guy out. So we have x squared minus 3. So x squared minus 3 is going to be a parabola that's opening up, and then you're down 3 units. Okay, so you start here, and then you know that you're going to be facing up. So you can plug in 1, and so when you plug in 1, you get 1 minus 3, so you're at -2. And then when you plug in 2, that's your other bound. You're bounded at 2. When you plug in 2, you get 4 minus 3, so that's positive 1. Okay, so that's your curve. We're only between 1 and 2. So we're this curve here. So if we are trying to find the area between 1 and 2, so this is 1 and this is 2, then we are finding this area here and then this area here. So it's going to be small. And then looking at your graph, you know I have more area below the x-axis than I do above the x-axis. So already, just from that, I know that my answer to this integral will be a negative number, because this is going to be a negative number, that's going to be a positive number, and I can see that this negative is larger than this positive area, so I know my answer is going to be negative. So then if I want to estimate it, I can, and so I can say, okay, well, this kind of looks like a triangle, so I could estimate it with a triangle formula, so half base times height. So I know my height is 2, and my base, I don't know, looks like 3/4 or something. So maybe it's 3/4. I'm not really sure, but it's an estimation. Okay, so this area down here, if those would cancel, so I'd get 3/4. And so that area, it would be negative, right, because it's below the x-axis. So that area is negative 3/4. Then if I estimate this, this also kind of looks like a triangle. You could also look at it as from here to here, this box would be an area of 1, right? That's 1 by 1. So this looks like it's, I don't know, like a third of the box, maybe a quarter of the box. I'm not really sure, but it looks, maybe like a quarter. So if that area is positive a quarter, then my net area for this being negative 3/4 and this being positive 1/4, then I would be able to say, okay, so that plus my negative 3/4 would get me negative 2/4, which is negative half. So that would be my approximated area. So definitely squiggly, right? Definitely an approximation. I really don't know what it is, but I at least know, like, at the end, if I'm something around like negative half, I'm probably right. So just to keep you, in line as you're going through, that you have a ballpark answer. All right, so to evaluate this, we know how to find the antiderivative. So just by our power rule, we know, okay, x squared, I can take that integral. I would bump it up 1. So I could take that integral by saying that is then x cubed, and then you divide by that number. And then taking the integral of a constant, you would have minus 3x. Okay, and then you have your constant of integration. Okay, so that's our antiderivative, just our first line. Okay, but then what's different is that we actually have this 1 and the 2. So what we do there is, the notation we have is that this is our antiderivative, our general antiderivative. So to get our particular solution of actually evaluating this to get an area, because we're going for a number, right? We want like a number. We don't want an equation or expression. We want a number. So we have this, and the notation we do is we say, okay, but I'm looking at it from 1 to 2. So the notation I use is a bracket just on the right side, and I say I am looking at it between 1 and 2. Okay, so you did your antiderivative just like normal. Then you're bounded between 1 and 2, just like we were here, right? So we had a bound here at 1, we had a bound here at 2. So now what I do is I use my fundamental theorem. So I had my integral, and my little f is x squared minus 3. I found my antiderivative. My antiderivative was this. Now I just need to plug it in. So take your antiderivative, plug in b, and then subtract when you plug in a. So you plug in b, see what that number is, plug in a, see what that number is, you subtract those two numbers. So we're almost there. So now this is our antiderivative, this is our big F. We plug in 2, see what that number is, plug in 1, see what that number is, and then you subtract it. So first let's plug in 2, so it would be 2 cubed over 3 minus 3 times 2 plus c. So that I plugged in 2, so that's like my f of b. Okay, minus, okay, there's minus, my f of a. So now plug in 1. So that's 1 cubed over 3 minus 3 times 1, and then plus c. Okay, so looking at this algebra, okay, so we're just plugging in those numbers. I can see that a few things cancel. So like this c minus c, they would be gone. Okay, so your constants of integration actually end up canceling when you have numbers here. So that would be a c and a minus c. So then here we would get 8/3 minus 9. Okay, so then if we get a common denominator there, we'll have negative 10/3. Okay, and then minus, just that minus sign coming straight down. This would be 1/3 minus 3. So if we get a common denominator and subtract that, you get negative 8/3. Okay, so we have 10/3, that was this, minus negative 8/3, that was this. Okay, so then I get negative 10/3 minus a negative 8/3 plus plus. So then my final answer would be negative 2/3. Okay, and then just always check that your estimation was accurate. So we thought that it was around negative half, and so yeah, negative 2/3. That's close. I would say, yeah, that could be negative 2/3, a net area for below and above. Okay, so then that is our final answer. Okay, so try B on your own. Okay, so go ahead and pause the video. Try B on your own. Go through the integral, then try to plug in your A and your B just like we did in example A, and then just check back that you got the right answer. Okay, so you should have already done this one. So with this, you pull out the 3. So you get the integral from 1 to 4 of rad x dx. Okay, you might want to rewrite that as x to the half, if that makes you feel better. So you have x to the half dx. So then he's a polynomial, so x to the half, you bump it up 1. So you would get x to the 3 halves over 3 halves, right? But then if you have 3 halves in the denominator, you would take the reciprocal and you would get 2/3. Okay, and that 3 is still there. Okay, and then you would have that constant of integration, but we saw in this last one that your constant of integration actually cancels out, so you don't need to write your constant of integration if you have specific A and B values. So now you're here, okay, and we have specific A and B values, so we write in our bracket, we're between 1 and 4. So then we plug in. So we know that these 3's canceled, right? So we plug in for the 4, that's our f of b, and then we plug in our 1, that's our f of a, and then we'll subtract those. So we have 2, and we're plugging in 4. 4 to the 3 halves is equivalent to 4 to the half cubed, right? Because you would multiply these. So 3 halves is the same as half cubed. Okay, so that would be 4. And then minus, now do f of a. So now plug in 1. So 2, I'm going to do the same thing. 1 to the half cubed. Okay, so now the reason I split this up is because I don't know what 4 to the 3 halves is, but I know what 4 to the half is, right? That's the square root of 4. So the square root of 4 is 2. And then 2 cubed is 8. So then I'm 2 times 8. Okay, and then over here, 1 to the half is the square root of 1. I know that. The square root of 1 is 1. 1 cubed is 1. So then I'm minus 2. Okay, so then my final answer here is 14. All right, your next one is a trigonometric. And so for this one, secant squared is one that you should have memorized. So the integral of secant squared is tangent. And then we're at definite integral, because okay, we have these bounds. So we're tangent, and we're between 0 and pi over 4. Okay, and this is where that unit circle comes back. So you have to find f of b minus f of a. So you're going to evaluate those. So tan of pi over 4 minus tan of 0. Okay, and so the tangent of pi over 4, okay, remember that pi over 4 has the same sine and cosine, both rad 2 over 2. And so the tangent of that would be sine over cosine, and so that is 1. And then minus tan of 0, okay, 0 is here, okay, and that, okay, is you have 1 comma 0 there. So that one is your cosine, this one is your sine. So if you are sine over cosine for tangent, sine over cosine is 0 over 1, and 0 over 1 is 0. So you're 1 minus 0. So then your answer there is 1. Okay, so if you are kind of iffy on your unit circle, make sure that you study up on that, because you will have to use those when you have your definite integrals. All right, D, we have another polynomial. Okay, so with all of these, they're polynomials, so you bump it up 1 and then you divide by that number. So this one's going to be x, and 4/3 plus 1 is 4/3 plus 3/3. So that's 7/3. Then you're over 7/3. Okay, this one you have a 4 out front, and then you bump up the 1/3. So 1/3 plus 3/3 is 4/3, and then you're over 4/3. Okay, and from there, okay, you need to then know, okay, I don't have a constant of integration because I can actually plug in. So I'm between -1 and 1. So to kind of clean this up before you start, this 7/3, you take the reciprocal and it becomes 3/7 x to the 7/3. This one would become 3/4 when you take the reciprocal, which then if you become 3/4, then the 4's cancel. So you end up having 3x to the 4/3. You're between 1 and -1. Okay, so now you do your big F of B minus big F of A. So you plug in your B and then you plug in your A. So you have your first one is 3/7. Okay, lucky for you, it's just ones, so I can take the cube root of 1 all day. I'm good with that. So you have 3/7, and that would be +1. Okay, so 1 to the 7th is 1. The cube root of 1 is 1, so I'm just 3/7. Okay, plus 3. I'm still plugging in 1, right? So if I plug in 1, I take it to the 4th. It's still 1. The cube root of 1 is 1, so 3/7 plus 3. So that's F of B. Right, minus F of A. So then 3/7, if I take a negative, -1 to the 7th is -1. The cube root of -1 is negative. So this is -3/7. Okay, and then if I plug in -1 here, -1 to the 4th is +1. The cube root of +1 is 1. So that's +3. Okay. And then you can either combine like terms here or get a common denominator, all that stuff, or you can notice that you have 3/7 minus another -3/7, and then you have a 3 minus a 3. So you can just see, okay, I have a 3 minus a 3, so those would cancel to 0. And then you have 3/7 minus a -3/7. So that would be 6/7. So your answer for this one is 6/7. All right, so that will be as far as we will go today. So make sure that you are okay with those problems and then the first lesson that you should have done. So this is the end of that lesson. So we'll finish up the rest of those examples on Monday.